Welcome to the Real Python Podcast. This is episode 123. How does a code completion tool work? What is an abstract syntax tree and how is it created in Python? How does an AST help you write programs and projects that inspect and modify your Python code? This week on the show, Meredydd Luff, co-founder of Anvil, shares his PyCon talk, Building a Python Code Completer. Meredydd talks about his experience building a code completion engine for the Anvil platform. The conversation leads us to discuss how Python parses the code you type. We examine tokenization, abstract syntax trees, and how parsing has changed in Python. We cover additional projects you can explore once you have a tool that inspects the Python code you're writing. Join us as we dive into multiple rabbit holes of research and exploration. This episode is brought to you by CData software, the easiest way to connect Python with data. SQL access to more than 250 cloud applications and data sources. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Meredydd, welcome back.
Hello, it's great to be here.
Yeah, it was so nice to talk to you back in episode 63. We were talking about creating web applications using only Python, working with Anvil. Then we finally got to meet up at PyCon 2022 in person.
Yes, I have owed you a drink for a very long time, and it was lovely to be able to deliver.
Yeah, that was great. And you also had a talk that you gave there talking about some new things that you were working on within the Anvil platform. And your talk was about building a Python code completer, and you were doing that yourself inside of Anvil.
Sure. So this talk was about a subject I really love because it was about code completion, which is one of those things that almost every programmer uses. It's that little pop-up box you see in your editor offering to autocomplete, your variable names, your identifiers, and so on. And almost all of us use it, but a lot of us don't actually know what's under the hood. It's magic to us.
Yeah.
And for reasons that I'll get into if we like about why Anvil specifically needed this, I ended up having to build one of these things myself. And what that meant is I got to work out how they actually work. And it turns out these things are really cool. They are in this magic overlap between things that feel like magic and things that are actually really simple. And so in the talk you saw, I talked about why code completion is a thing, and then how it works. And I'm not going to try and do this on a podcast, but I then built a code completer live on stage in about 5 minutes just to prove that it wasn't actually that hard. Yeah, so it was a really fun talk.
Yeah, we'll definitely include a link to the YouTube talk there.
Sure. All right. Well, let me try and explain the basics then. The goal of code completion is to answer the question, what might the programmer type next? So if you're building a programming environment, you're building an editor like VS Code or PyCharm, what you want is to have some idea of what might happen next, where the cursor is, because then you can offer these pop-up autocompletions. And what that means you need to do is to understand this half-written program that's sitting there in your text editor. This is a pretty daunting task. If you're thinking about it as, well, I've got this string of text and somewhere in it is a cursor, and I've got to work out what they might type next, because that means understanding the program they're in the middle of writing. If what they might type next might be a local variable, well, is that cursor in a place where a variable would be an appropriate thing to type next?
Yeah.
What local variables are defined in that program? And if you wanted to step through your text character by character to work that out, that would be not quite impossible, but incredibly difficult. But if you think about it, that's actually pretty much exactly the same challenge that you have if you're writing a programming language. Because something like, the Python interpreter, when you write your Python myscript.py, it reads in that file, myscript.py, and it doesn't go through it character by character as it executes, reading each line as it goes. That would be a very inefficient way of running your code. It also solves this problem. It takes that code, it takes that string of bytes and turns it into a more useful representation. So what it does, it's got a piece of code in it called a parser, and it will feed that string to the parser. The parser takes this string, walks across it, and produces a tree of objects representing your program. So, instead of a series of characters with, some number of spaces and comments and DEF and, some function name and then brackets,
right,
it instead has like an object that says there's a function definition. Its name is my function. It has, these three arguments, X, Y, and Z. And it has, 3 statements inside it. And the first one is to a function called print. And the second one is an if statement. And, here's its expression and some statements in the if branch and some statements in the else branch. And that is just a tree of objects. And that is much, much, much easier to work with.
Yeah, definitely.
Because, you can write a loop over this. So, and that's what the Python interpreter does. So it reads this stuff in, gets an AST, abstract syntax tree, and then walks over this tree, generating bytecode in Python's case. But any compiler works the same way. You have C compilers that go out generating, intermediate language to translate into machine code, because they've transformed the program into a format that's easier to work with. And as a developer of code completion, we can do the same thing. We can use this technology. If you just take your half-written program with a cursor in the middle of it, you replace the cursor with a random special symbol, and then you feed that to the parser, you'll get back an AST that describes this half-written program, but somewhere in this half-written program will be your cursor.
Okay.
And then what you can do is you can walk over this AST recursively, and as you pass every piece of the program, you build up a representation of what's going on. So, you read a variable declaration, x equals 5, or rather assign the constant number 5 to the variable x because it's been passed to that level of abstraction by this point. You pass that and you go, oh, well, I know there's a local variable called x, and I know that it's an integer. And then you pass into this def function. And then once you're walking through the statements inside that function, well, now hey, the arguments to this function, they exist as local variables. And so by the time you reach the cursor, what's going on in your program, what position the cursor's in, is this a place where it would be sensible to put a variable? And if so, all the variables that are in scope at that point in the program. And so you can offer a contextually sensible set of completions.
Yeah.
And that's the fundamental basis of code completion. You take the code that's half edited in the editor, you feed it to a parser, and then you use that parser to work out what's going on in the code and what's going on around the cursor.
So I have a couple questions that I wanted to kind of
go on.
Highlight in there. The first is you use the term recursively, which to me feels like it can have lots of different kind of interesting meanings as far as programming concerned. In this case, you're saying it's going to recursively or repeatedly look at the code and sort of refresh what the tree looks like?
Oh, well, I was talking about it in the simple sense, in that you've got this, it's a tree-shaped object. So you've got a module object, and inside it's got a list. It's literally a Python list. So Python has this amazing thing. It exposes its parser to us as programmers. So if you import AST in any Python program, you have access to this. So you can call ast.parse and pass it in a string of Python source code, and it will give you back a code object. And what you'll get back is an object of type module. And it has an attribute called body, which is a Python list of other code objects, other statements in this module. And if you define a function in this module, one of them is going to be a def function, and that will also have a body that has a list of statements. And so when I mean recursively walk down it, I mean literally you'll write a function that will iterate through these the statements in your module, and then when it encounters something that itself has statements inside it, like an if statement or a function definition,
it drills into them.
Yeah, it drills in, and then it just calls itself recursively to walk into those.
Okay, cool. And then I feel like one of the steps that it's going to need to do in this process of structurally creating this tree is define, what objects are what, sort of, I guess the term that I've seen, because I went down a whole rabbit hole after your talk and then into this whole thing. And I actually, I definitely do suggest you, if you're interested in this stuff, the abstract syntax trees, the AST documentation from python.org is really good. And it actually, as you're talking about this stuff, to have it open while we're talking about it might be a kind of cool thing, unless you're driving, to kind of look at, and you could kind of see it's, really well done inside there. But I think part of it is it's going to have to kind of create these sort of tokens. Is a tokenizer part of that process then?
Oh gosh. Okay. Let's do this. Let's talk about parsing. So I just talked about parsing as this black box. A parser is a program or a chunk of code that you give it a string and it gives you back an AST. Now, of course, there's a lot of machinery inside that, and in fact, the really cool thing about a parser is that most parsers were never written by a human being.
Okay.
So instead, if you go to the Python documentation, you can find something called a grammar file.
Yeah.
And that's a text file specifying everything that could make up a valid Python program. So, it will say, well, an if statement in Python is made of the word if, then an expression, then a colon, and then a block of Python code, and then maybe an else statement. Sorry, maybe the word else, then a colon, then another block. Maybe the word elif, then a colon, then another block, then elif again, or else, or nothing.
Yeah.
And you will find like reams and reams and reams of this stuff describing every building block of the Python language, every way you could possibly put together a valid Python program. And you feed that into something called a parser generator. And that parser generator spits out code for a parser. So, and this has been in the news recently because Python recently got a new one of these. We moved from the previous parser to something called the
Do you know the name
generator.
of the original one?
It was, I don't think it even had a name. It was just called the Python parser.
It's literally called pgen. It's called pgen. Parser generator. It's like 30 years ago. I have a link to the talk where Guido was, describing his experimentations, and this is like from 2019 as he's, thinking about let's move toward the peg parser, and I was like, okay, they just were calling it pgen, which I think is great.
So let's think about things in terms of the classic parser then. The original version that Guido was talking about in 2019.
Yeah.
The actual process, if you break it down, is you take this string of stuff, and then you feed it into something called the tokenizer that you were talking about.
Okay.
And what that does is it breaks the string up into chunks that are slightly more semantically meaningful than just a string of bytes. It will, there could be like variable identifiers, or like a quote, string literal, or in Python, actually, the tokenizer is quite clever, and it also understands like indents and dedents, because of course white space means things in Python, and so it's actually the tokenizer's job to count how many spaces you have at the start of your line, and then emit this series of tokens. So instead of this file of bytes, you get, this has the word print, then an open parenthesis token, then a string literal token that has this contents, then a closed parenthesis token, then an if token, then some other token, then a colon token, then an indent, and then some series of things. So it's sort of pre-processed your text into some series of objects, but it's still like a flat linear sequence.
CData software. Connect, integrate, and automate your data from Python or any other application or tool. At CData, we simplify connectivity between all of the applications and data sources that power business, making it easier to unlock the value of data. Our SQL-based connectors streamline data access, making it easy to access real-time data from on-premise or cloud databases, SaaS, APIs, NoSQL, and big data. Check out CData.com to learn more. Can I ask you a quick question on what you were building inside of Anvil, this tool that you were creating?
Yes.
Is that tokenizer, is that a separate step? Because like a common way that people would see that maybe in an IDE is that it will start to just color code your text as you go. It's like, oh, I know what Python is.
Yeah.
And it'll identify and start highlighting that stuff. Was that a separate thing that was created?
Oh my goodness. Okay, yes. So it's an Anvil specifically. For those who have not gone back and listened to the previous episode with me, shame on you. But also, quick summary of Anvil. So this is what we're talking about. Anvil is an online environment for creating web applications entirely in Python. So it's got like a drag and drop editor for building user interfaces, and it's also then got a code editor, and you write Python code. Some Python code that runs in the web browser, some Python code that runs on the server, and you can call functions in one from the other, and then you have a built-in database, and you can deploy it all, and you don't need to know HTML, CSS, JavaScript, React, Redux, Webpack, all that stuff. You can build a web application even if all you know is Python. Now, this means a couple of things. One, it means that I maintain an online code editor, which has some of this stuff like syntax highlighting that you're talking about.
Right. And
another is that this is why I got interested in all of this in the first place, because we also have our own code completer that runs as part of this editor. But so the thing you're asking about is if you're in this online editor and as you're typing, if you type the word for, then the editor will sort of syntax highlight that.
Yeah.
And that is, yes, you're right. A way this can happen, and many editors do this in many different ways, but a way this can happen is you feed what's in the editor to a tokenizer really fast as people are typing. Sometimes the editor component actually has like a rudimentary parser built into it. So it has some sense of what's going on in your code, but it probably isn't a full parser, probably doesn't actually generate an AST, but it can go part way through the parsing process.
Okay.
So, it knows about your indents and dedents. And so, when you hit enter, it can work out how far, when you type if x : enter, it knows enough about Python to know that you should be, 4 spaces in on the next line, that kind of thing.
Okay.
It's kind of it's like slightly more than a tokenizer, but maybe like the first half of a parser usually.
All right.
But but we're going off in all sorts of different directions. Let's walk through how a full fat parser works.
Okay.
So you get your text, you fed it to a tokenizer. So now you've got this string of tokens, and you've usually by this point you've omitted the comments and stuff. Now you have a job of turning this flat string of tokens into a tree that people can use. And in the classical world, what you will then do is you will do the parse step. So the parser generator will have produced a machine that you can give a stream of tokens to, and it will produce a tree of objects representing the code that it's just been fed. But a general parser like that, a table-driven parser, doesn't actually know about the semantics of your programming language. And so it will produce what's called a concrete syntax tree.
Okay.
So this is really quite an unpleasant thing, because it doesn't know that this is a function definition with statements in it. It just knows that this is this thing of this type that you happen to have assigned the word function to, but I don't really know about this. And, here's this sequence of tokens that I parse into this sort of thing. And then you would write another piece of code in the C Python. This was called ast.c, which went over this concrete syntax tree, worked out kind of what was going on in the Python program, and then generated an abstract syntax tree. Let me give you a concrete example. So when you parse like a raise statement, there are a few different ways to write raise in Python. You can just raise and then type error, and that's it. That's a complete statement. Or you can like raise and then type error brackets, and or instantiate the exception object. Or you can actually have raise in like various forms with like commas between them. And in the concrete syntax tree, those would all be represented differently because your table-driven parser doesn't really understand the differences between those things. It just knows there's three different ways of parsing this thing, and so it'll offer you all three of them. And the ast.c had the responsibility of looking at all these different ways you could write a raise statement and sort of homogenizing them, unifying them into an AST node that was just the raise statement that had Python meaningful semantic attributes.
Nice.
So that's the old way things used to go. So you took your text, you tokenized it into tokens, then you parsed it into a concrete syntax tree, and then you ran the ASTifier, I'm sure it has a proper name, over it to generate the AST nodes. And then you went on and compiled it as normal. But what Python moved to recently was a new parser, which it does two things. One is that it's a different strategy for doing parser generators, which just has a different way of approaching this stuff, which I'm not going to try to explain because explaining table-driven parsers.
Well, I think I could do like my own short version of it that I kind of
go and hit me.
Recently watched some talks on it and so forth. The original parser, the LL1 parser, focused kind of on like one token at a time, and part of the reason was that was like the earliest design in that sense.
Mm-hmm.
When Guido kind of came back and started to see like this idea, he decided to take a break from Python for a little bit there. He stepped down as the BDFL and said, I'm going to take a little break, right? And he, during his retirement, couldn't stay away, I guess, and started really in getting interested in the idea of what's a different way that we could parse? And computers have changed. It's been 27 years, almost 30 years at the time he was looking at it. Memory is no longer quite the issue that it used to be. Parsing a text file is not that big a deal comparatively to like, graphics and all these other things that computers are doing now. And so what if the thing could look further ahead and be able to kind of look deeper into the context? And so now it has, with this new methodology, instead of going individual token by token, I guess it can have infinite look ahead is the concept of it.
Yeah, that's
really wild. Yeah. And
that's a good summary. Go on, sorry, finish.
Okay. Yeah. And so that has helped a lot with all these other really kind of cool things that sort of have been unlocked, in that the grammar used to really get stuck on certain words. So the idea of like the case switch statement.
Oh yeah, the match statement.
Yeah, the match statement before, like the idea of a case or these other kinds of words potentially could be given a different token, or like potentially could have an issue and so forth. And so now it's able to kind of read ahead into that. And probably the coolest thing that I've found come out of it, and as far as someone getting into Python and learning about it, is this ability to read ahead and kind of figure out through the syntax errors. And what were you trying to do potentially syntactically, as opposed to just like hard stop, like boom, syntax error, this doesn't make sense. It could kind of maybe read ahead and say, were you trying to do this? And some really interesting stuff happening there that, Pablo Glunda Salgado, and he's kind of leading on some of it. And I just kind of found out that he was helping in some of these explorations with Guido on it. And so anyways, a lot of neat stuff. And I'll definitely include links for all that stuff if you want to geek out and dive into it. But that peg parser, I guess, was introduced in 3.9 kind of late, almost like in a testing mode. And then in 3.10, it's the parser, so basically everything going forward 3.10, 3.11 and so forth is all peg and allows all these new kind of cool functionalities. And hopefully might be part of why we can speed up too, which maybe that's a separate conversation generally. So
I think that is probably a separate conversation, because unfortunately that's all this far side of the AST. But my goodness, you were not kidding when you said you went down the rabbit hole.
Yeah, it's been fun.
Oh yeah,
my brain hurts a little bit. I was telling you offline before we started. I started to dig into, like, okay, what is an abstract syntax tree, and versus this and so forth. And I'm part of it ended up being that this whole thing where I feel like I was reading legal contracts with all these big words that nobody's defining for you anywhere, and you have to go and find them. And like, okay, EBNF.
Oh gosh, yes,
stuff like that.
Extended Bacchus-Naur form, obviously. Yes, absolutely. I think it is true that some of this stuff can be abstruse, but I think one of the things I was really trying to get across in the talk is that it's actually doesn't have to be this scary.
No. I mean, compared to even the English language, like, you can read all the grammar on a page, which is pretty cool.
No, and not just that, it's that you can play with it. You can import AST and AST.parse like a simple Python program, like in your REPL right now.
Yeah.
Probably, without pausing this podcast for more than 30 seconds. And there are actually, you were showing me before the show.
A website.
Wonderful
Python AST. So python-ast-explorer.com. You can see it, as you type Python in one box, it basically is building it on the right, which is really neat.
Yeah.
And then there's examples in there too. So
yeah. And again, like I would don't just look at that. Like, really do. I feel like something powerful happens when you actually write a program that does that yourself.
Yeah.
And once you realize that you can have programmatic access to what your code is doing, there are suddenly so many projects that you now can take on. Like, building a code completer seems impossible until you realize, oh wait, I can use a parser. And like, Python has it there at your fingertips, that there's so much fun you can have once you actually pick this tool up and start playing with it yourself.
Yeah. To kind of get back to your parser, there's a couple questions I have about it. One is about scope, and kind of you kind of navigate a lot of that in your talk, which I think is great.
Mm-hmm.
And then also kind of, I don't know what to call it, other than sort of the data structure that's going to hold these options, if you will, for the code completer to put in. And maybe we could talk a little bit about those things.
All right. Okay, well, in which case, if we're going back, we should probably finish the train of thought we were on originally, which is like the difference between how the peg parser works and the classic one. And the only salient difference I wanted to call out among the other great features of the peg parser, of which you gave a kind of summary, like, basically, a peg parser is quite easy to understand. It just like, it's a recursive, hey, see how far I can go down this branch. Like, at any given point, there are a few things that you could be writing. And just like go down each branch until you find some reason you can't get to the end of that branch, and then, if not, backtrack and try everything else. It's kind of like, it's a depth first search on all the possible ways to interpret the sequence of tokens in your program. It's really cool. But the other really cool thing about the peg parser is that it doesn't actually go via concrete syntax tree. It goes straight to AST.
Oh, okay.
So this parser generator goes from your tokens to spitting your AST straight out, which I think is really quite cool, especially I'm also one of the maintainers of the Sculpt Python to JavaScript compiler, which is obviously, that's the Python implementation that Anvil uses to run Python on the front end of the web browser. And that means I maintain a Python implementation, which means I deal with the concrete to AST compiler all the time, and it is going to be so great. We are also adopting the peg parser into Sculpt. It's not done yet, but it's going to be, and it's going to be so much nicer when just the AST drops out fully formed.
That's cool.
It just really is a quality of life improvement for people who are working on the interpreter.
I bet. I wonder if a lot of people think that, that
I hope so.
I guess with that you're building these tools, and so you can kind of see it up front.
Yeah. Oh yeah, I mean, likewise, that's going to be helping people on the CPython team do their jobs. But again, the easier their jobs are, the more fun they can have building things like match statements and the walrus operator, and hopefully making Python faster.
Yeah.
All right, so we were at sorry, before we diverted into there, you asked me about
scope and and then like sort of a data structure to hold these potential completables.
So this is the second part, and this is actually the fun challenge of writing a code completer, because you now have this AST, you're walking over it, and I've waved my hands and I've said you're building up a representation of what's going on as you walk your way through the program. But you need to decide how you're going to do that. And in my talk, I built a very simple completer. I mean, I only had 5 minutes. I was on stage. The completer I had used a set object to hold the names of all the variables that were in scope.
Okay.
And the only thing it could complete was what variables might I be using. And so that was pretty easy. Every time you walked into a function, you made a copy of the stuff of the scope on the outside, and then to that copy you added all the function arguments. And then as you were walking through the function body, when you saw a new assignment, you added it to that inner scope. And then once you were done with the function, as you sort of return from that nested call, you just drop that scope on the floor, and there was nothing else to do with it. That's fine if all you're doing is seeing what local variables are in scope. But actually, you want to do a lot more than that. You want to know some stuff about types.
Yeah.
Now, when I say the word types, you might be thinking strongly typed languages like Rust, or you might be thinking about Python's typing module. And those are kind of type hints. But I think I really encourage you, if you're thinking about things from the perspective of a code completer, you should think about types in the academic sense, which is everything we know about what could be or what this value might be. So, yes, you could know that for sure that the variable x currently contains an instance of the string class. And so if you type x dot, you should probably offer all of the attributes that you know that string instances have, to, lower, and trim, and so on.
Right. Okay.
And that's a simple version of type information. But you can record a lot more than that. You can know, that this was actually a string constant defined here, or you can know. I mean, the classic one that I talk about is dictionaries. So you can have two dictionaries that have different sets of keys. And those are both going to be instances of the dict class in Python. As far as the Python interpreter is concerned, they have the same type. If you call type on one dict and type on the other, you will get returned the same object, the dict class. But from the perspective of a human writing code, those are two different types of dict. You can use square bracket lookups to look up different keys in each of them. And if you are building, say, code completion, it might be useful to, if somebody types my dict and then the left square bracket, you want to know what options to offer them. And you might want to offer them you'll offer them the keys that that dictionary has. And so what you need to store is type information about that variable that is more extensive than just what Python type that value will have, or just, the Python type hints of that variable. So you have this challenge. You want to store basically arbitrary amounts of information about these values, and you want to be able to update them as well. Because if you think about how Python, if you're writing a Python class, you define what attributes that class has in the init method.
Okay. Yeah.
Everything in Python is so dynamic. If I'm writing a class for potato, and it has its attributes of the weight in grams and the temperature in degrees, I define that by having the dunder init method go self.weight equals weight, self.temperature equals temperature, and that's really the only way I ever say instances of the potato class have these two attributes. And so what that means is that your autocompleter has got to recognize that. And so what the structure that we ended up with is we did something similar to what you'll see me do in that talk, which is that we have this recursive call. Every block of code is handled by an invocation of a function. There's a function called walk block that walks a series of statements in a block, and then if it encounters a sub block, like inside an if statement or a function definition or a try except, this is Python, it will sort of recursively call another walk block inside it. But we also stored the top level module scope, which as a dictionary. So a dictionary of like the name in that scope, variable name, to an object that represents the type.
Okay.
And then that object has lots and lots and lots of attributes. Sure, it has, it has a name of, hey, what the Python class is, but it's also, and what attributes that class has, attrs, but it also has information like, if this is a thing that you can look up in with square brackets, so you can call get item on it, what items are in it? What are the types of those items?
Yeah, okay.
If this thing is a function, what arguments does it take? Can you call it? What arguments does it take if you call it? What type does it return? If you call this thing, what type will it return? These things are mutable objects, because as you walk through, let's imagine we have a simple program that defines the class potato and then creates a new instance of that and then prints its temperature.
Okay.
Well, then as you walk through this program from top to bottom, the first thing you'll see is the class definition, and you'll walk through that. Inside that, you'll find a definition of the init function. And so your top level module scope now has a class called potato in it, and that potato, its scope now has this init function in it. And as you walk through the init function, you have to know that I am walking the init function of the potato class, and self is an instance of potato. And then when you type, I can't believe I chose potato for this. The word potato is going to lose all meaning here.
It's okay.
When you type self.weight equals weight,
yeah,
you have to know, hey, this is a dynamic addition of an attribute to the potato class. I'm going to mutate my representation of that to go, hey, I now have learned something new. This thing has an attribute called weight, and and it's an integer, possibly.
Yeah.
So you have to make up your own data structure, and I don't know for sure what other completion systems use. There are a bunch of completion systems out there. Some of them are proprietary, like open source, like the completers built into PyCharm. There's the various code completers used by VS Code, and there's one called Jedi, which is the cool Python code completion package. Everybody does it slightly differently because everybody wants to represent what's going on in their code in a different way. But you've got to make this decision. How do I represent a language as dynamic as Python?
Yeah.
How do I guess? Python is full of dynamism.
Yeah, it comes up all the time.
You can dynamically add extra attributes to objects. You can dynamically decide whether you define a function. Like, you can put the function definition inside an if statement. That is perfectly legitimate behavior. And so your code completer is always looking at your code and guessing.
Yeah, and you think about it needing to be dynamic. This code completer needs to be extremely dynamic. Like, it's having to change stuff.
Well, it's not just dynamic. It also just doesn't know what's going to happen.
Yeah.
There's this theorem in computer science. It's the halting problem, Turing incompleteness. The idea is it is provably impossible to understand what will happen when you run a program by looking at it.
Yeah.
If you're not running the program, you do not know what it will do. And even if you're halfway through running the program, you don't know what it will do. Which means that your code completer doesn't actually know for sure whether some piece of code that adds an extra attribute onto the potato class will run every time, sometimes, or never. And so it has to make a guess about when these attributes will actually exist on various instances of potato. And that's okay. It's guessing all the time, because it doesn't matter. Well, it matters to get it right. But if you're building an autocompleter, I like to say it's like making the graphics for a computer game. You don't need perfect physical accuracy. What you need is to make the human in front of the computer happy.
Right.
So when you're faced with a language as dynamic as Python, it's not just that you have to be dynamic yourself. You have to acknowledge you don't know exactly what the program's going to do, and you have to approximate, you have to guess.
This week, I want to shine a spotlight on another Real Python video course. Each version of Python adds new features to the language. And for Python 3.8, the biggest change was the addition of assignment expressions. This course is titled Python Assignment Expressions and Using the Walrus Operator. It's based on a Real Python tutorial by previous guest Gerarna Hjella. And in the course, instructor Darren Jones shows you how to identify the walrus operator and its meaning, avoid repetitive code by using assignment expressions, convert between code using the walrus operator and code using other assignment methods, how to understand the impacts on backward compatibility when using the operator, and how to use appropriate style within your assignment expressions. We're a couple years past the controversy surrounding the introduction of assignment expressions, and you're likely seeing their use in code more often. I think it's a good investment of your time to learn how to take advantage of this operator and how to understand its use in the code you may review. Like most of the video courses on Real Python, the course is broken into easily consumable sections. You get code examples for the techniques shown, and all courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. When you went through this process of, thinking about diving into this, was it the first time you've worked on a code completer? And then also, did you go and look at other systems, or you said some of them were open source? Were they useful to look at, or was that something that you approached when you did this project?
I'm not going to say I didn't take a glance, but it was mostly a from scratch implementation.
Yeah.
I think part of this is, as you alluded to, in how you want to represent your types, because when we were building a code completer specifically for Anvil, and we were doing that for a couple of reasons. One of them, sure, was that this is a web-based editor, and so there's just not a lot of time between keystrokes when a programmer is really going for it. You don't have 300 milliseconds to go back to some web server, do some code completion, and come back with a set of possibilities. Your programmer is like 3 words on by the time you've come back to them.
Yeah, it goes back to your computer graphics thing there. Like,
yeah,
if the controls are going to be that
janky,
floaty, you're just like, ugh.
No, not going to bother. Exactly.
Yeah.
And crucially, it is more important to get the float controls non-floaty than to get that perfect iridescent sheen off the protagonist's head.
Right.
So we went, okay, well, so that's one reason for writing something that would run in the web browser, which means we couldn't use something off the shelf like Jedi, because that's expecting to see a set of files in a file system.
Okay.
So that's one reason for it. But the other reason that I think is more interesting is that we wanted to build a code completer for the same reasons that we wanted to build Anvil itself. Anvil's goal is to solve this problem where you have to write, SQL to talk to your database, Python on the server side, munge everything over HTTP, write, HTML and JavaScript and CSS and make them all work together with all sorts of frameworks.
Right. The graphical user interface stuff, all that stuff. Yeah.
What that means is that in a typical program, you don't actually know what the database is going to give you, because your code editor doesn't understand the SQL you just fed the database, so it doesn't know what kind of data it's coming back. When you're writing your front end, you've just hit an HTTP endpoint. Your code editor doesn't know what shape of data is going to come back. But because Anvil's an integrated environment, you write the server and the client code, which means that when you call server code from the client, we've seen that Python function, we've parsed it, we know what it's going to give back. And so we wanted the code completion to reflect that. Likewise, there's a built-in database. And so when you query the database, you get back these live Python objects and, use square brackets to look up the columns. And then you can pass these objects from server to client. And again, they come out and you can look up the columns on them, you can search them, you can update them live. And that meant that the code completer for this system wanted to have a really good idea of the types of things. Deep typing, as I say, is more than just the Python class, of, oh, hey, this is actually a database row from the X table. And so it will therefore have these columns of these types. And then if I ask for a restricted column view that's only got these 3 columns, well, that will then give me a new table type object that when I search it, it'll only give me these 3 columns. And so having that kind of the level of information about type information in excess of what Python's classes or the typing module would give you is something that, it's really good to have a custom autocomplete.
Yeah, it's a lot of assistance you're providing.
Yeah. It was a couple of years ago at PyCon, we were talking to the VS Code guys on the Microsoft stand, and they were saying, hey, you should totally have a VS Code plugin for Anvil, or write stubs for it. And then we showed them some of what our code completer does, and they went, oh, that would be difficult in our architecture. Yeah, we built it for this purpose. So yeah, obviously
it's unique. Yeah.
There are things where those code completers are more advanced, more complicated than ours, but one advantage we got is our representation of this internal state of types has a lot of space for knowing about things like, what components are on your screen, being able to work out, when you've built a user interface in Anvil, the class that represents that page has a set of attributes depending on what objects you've dragged and dropped onto your screen. And so it can live update, the types of those objects, the types of, if you have a repeating chunk of user interface and you feed it a set of database rows, it can look through your code, then look through your UI definition and work out, oh, well, when I'm editing the chunk of code that represents each row from this database, then the self.item, which is this element from the list, is an instance of that. It is an instance of that row from the database. And having it tightly coupled, meaning that we can design our data structures to reflect the stuff that's really important for building user interfaces in Anvil, was a thing that was really valuable for us.
Yeah, totally. One of the things that makes me think about that, you have this luxury of it all kind of being together and knowing what the parts are, and the database is part of the system and so forth, as opposed to being external. It makes me think a little bit about one of the arguments people have for typing in Python and adding it is, okay, if you add types to your programs or your packages and your modules, that the code completer in an IDE is going to have an easier go of it, if you will. It can kind of figure things out. And I feel like that's something that I wouldn't say without knowing that your stuff has got types in it across the board, but I would guess that it's kind of a similar process where you can kind of, the architecture a little bit better. Yeah.
I think so. Python's type hints. I mean, this is a fascinating topic all on its own. I'm sure you could do several episodes, probably with people who have more intimately connected with writing them than I am. The interesting thing about type hints is Python's type hints can express some stuff that the Python type system doesn't already know, which is itself interesting. But they're capable of lying.
Yeah.
You can tell MyPy or whatever type hint you're using that a variable is of a certain type, and then give it something of a completely different type, and nothing's going to explode at runtime.
Right.
Well, unless you are using Pydantic and then you're using the type annotations to configure a type checker that runs at runtime to make sure you've got the right the right shape of data. It's a very flexible mechanism. It's Python. But yeah, the idea of having these type hints in your code being explicit about making a promise that then you still are on the hook to follow is a very interesting design choice that I can see why it's gone that way and why it kind of fits with the Python philosophy. But you see this actually as well in, there's a very similar question with JavaScript and TypeScript. If you're using an editor that knows about TypeScript, if you're using the JetBrains WebStorm package, the code completer in WebStorm will often know more than TypeScript does about what type a variable is going to be, because it has inspected your code and it's done just that little bit more inference, and it's being just that little bit smarter than the TypeScript typing rules are. And so you will find that it will happily autocomplete code that the TypeScript compiler will then barf on.
Yeah.
And again, like basically, when you have a dynamic language and you try to put sort of promissory types that are just assertions about what's going to be happening in this dynamic language at runtime, you end up with all these really interesting corner cases. And actually, we don't, I mean, like, you can write the typing expressions. We don't currently lean very heavily on type hints in Anvil.
Okay.
It's, I mean, partially, we will get there, we will move that way, but partially that actually you can often do as well inferring by actually parsing and reading the code as you can by reading the type hints.
Yeah, cool. I feel like, we could, like, there's so many avenues we could go down, and we already kind of...
I know, like, this is one of these wonderful topics, and I hope, listeners, you're holding on. We are just having a great time here. I hope you're keeping up.
Well, I will provide a ton of links, not only the talk that you did, but all the other kind of avenues that I went down and explored, and lots of tools for you to play with.
Christopher Bailey going down the rabbit hole and reaching back and yanking everybody in after him.
Come on, let's go. We're late. One of the things I thought about is beyond building a code completer, which, I think is potentially a task that might be a little outside, the abilities of some intermediate developers. They might have a little hard time with it.
Well, so yeah, I'm going to go ahead and disagree with you there. I know I know you want to take this elsewhere,
okay,
but I don't think it is outside the abilities of an intermediate developer. Like, watch my presentation, watch what I did on stage. Like, it was a simple recursive function. Having the AST module there means it's not beyond your abilities.
Okay,
of an intermediate coder. Having said which,
you just got to get deeper into it. Yeah.
Having said which, it might not be a thing you need to do all the time. There are other projects available. Like, my introduction to, really bashing around with ASTs was, I took some compiler courses at university, but my proper hands-on introduction was writing a code completer, because writing a code completer is what I needed to do at the time.
Okay.
But there are all sorts of other fun things, which I think is where you were going with this. There are all sorts of other fun things you can do once you realize, oh, hey, I've got a parser, I can throw it at any code I like.
Yeah, one of the things that kind of came up in my search was that in the AST documentation from Python, docs.python.org, abstract syntax trees, they had this link to a kind of I thought, of interesting named site, which was called Green Tree Snakes. And it has examples of, getting to and from ASTs, modes, fixing, and so forth. A whole section called Meet the Nodes, and then working on the tree. And then at the end, it had examples of working with ASTs. And so they had a bunch of different things that you can kind of check out. And we already mentioned the, AST Explorer that you can kind of play with a little bit. And then one of the things they brought up was a linter. And the one they had as an example, which I think I just love the name. It's called Belly Button. So it's just a great name for a linter.
So what does this thing do?
So a linter, if you're not familiar with the terminology, you might have heard of things like Flake 8 or PyLint. But basically the idea is that it will go through and look at your code. And I don't know exactly if it auto formatting the way something like Black would, but in many cases, it's basically highlighting what it considers to be potential errors or potential things that are not following, some of the rules of Python.
Yeah.
And there's a set of rules that you kind of can dig into from there. And
so that's, so like if you used a variable before you defined it, say,
okay,
then a linter could complain about that in a way that the Python compiler won't until runtime.
Yeah.
And so I guess that's a perfect example of the kind of thing that you can absolutely do once you've got a parser, because the prospect of how would I detect undeclared variable use in a Python program, if all I've got is this bag of strings, is really scary.
Yeah.
But actually, if you have an AST, then walking over it and detecting that is actually going to be pretty straightforward.
Yeah. So anyway, I think it'd be a good project to kind of look at. Another one that, we mentioned Black already, the code formatter, which kind of is auto reformatting your code.
Well, the wonderful thing about that is that's also completely driven by the AST module, as at least last time I looked at how it worked under the hood. It just reads in your code, parses it. There's a mode to AST that preserves the comments, and then just like it gets an AST, and then in its opinionated way does the reverse and writes out text of the Python program that ought to produce that AST.
Yeah.
Which is that's a brilliant example of how to use it. I mean,
yeah,
hair-raising, but brilliant.
Yeah. And then the other ideas that were in there were maybe like a testing tool is going to potentially dive into the same kind of stuff.
Mm-hmm.
They referenced PyTest.
Oh, PyTest is a balmy one. PyTest. So if as a listener, if you haven't used PyTest, it's honestly, I'm going to say it, it's a bit unPythonic. All sorts of magic happens when you write a PyTest test. Like, the way you write a PyTest test is you define a function that begins with the word test, and then the arguments of that function, the name of those arguments will call forth test fixtures that you've defined earlier in your program, and implicitly, not explicitly, will cause those text fixtures to set up and pass their values in when that test is run. It is bonkers, and of course, it does this by really heavy inspection of the AST and bytecode of the program that you're running with PyTest. It's a bit brain melty, but yeah, talk about writing a code completer is absolutely something an intermediate programmer could tackle this afternoon as an interesting project.
Yeah.
Writing something like PyTest makes me want to climb a tree.
There's a massive team behind it. But I thought of something that could search for potentially security flaws.
I mean, there's
things like that.
Yeah. So at PyCon this year, I actually met up with they're going to be so annoyed that I can't remember the name of the company and give them free advertising here. But it was one of these companies that does code analysis for security vulnerabilities.
Yeah.
And actually, one of their developer advocates I ended up talking to was a former JVM, Java Virtual Machine core developer.
Oh, wow.
And so she'd been right up in the parser and compiler that drives the JVM. And now she was working it from the other side of okay, let's parse through your code and see if we can identify you doing anything silly.
Yeah. The other tool that we've talked about a few times on the show is something that has been interesting, kind of a back and forth with the new versions of Python, and it's this thing called Friendlier tracebacks, which is a really great kind of alternative REPL tool that for beginners can really help you learn through making mistakes. It's giving you a lot more information than just syntax error or type error or whatever. It actually is diving deeper and giving you a lot more information in it. And that code is online too, that you can most of these things are open in the sense that you can go and you can look at them and see how they're using the AST module to kind of do some of this stuff in the background. And PT-Python and B-Python are other alternative REPLs that have not only the stuff we were talking about earlier, the tokenizing and highlighting the code, but also auto-completion or code completion in a lot of cases. And so a lot of these kind of tools, I don't know, I kind of see how, if you're interested in making a command line tool or something like that, it's an interesting area for exploring as projects, and really a great way to learn more about how does this language function and what's going on.
Little sidebar, because this is clearly, the theme of theme of this episode.
All sidebars.
So there's that would be a good alternative name for the podcast. So when you're dealing with REPL tools that have auto-completion in them, it's interesting to if you look at them and try and work out, are they actually doing parsing on your code?
Okay.
And working out, what completion options to give you that way, or are they looking at the live objects in your program and offering you completion based on those.
But it would vary, right?
Yeah, well, and often they'll be doing both at the same time. So, you'll be halfway through typing an expression. It's using the parser to work out what you're typing because you haven't executed that code yet. But if you are typing X dot, it's going to go look, in the scope in which you're executing that REPL expression, find out what actual object instance X is, call dir on it, and give you the actual list of attributes of the live object, which is, again, one of those things it's really great. It can also be kind of confusing.
Yeah, dir has all the extra dunder methods and other things that potentially you're like, I'm not going to maybe use these.
It's not just the dunder methods. It's the way that, so this is something that often comes up when we talk about something like GitHub Co-pilot, which is right at the other end of the smartness spectrum here.
Yeah.
Which is like, it feels like, sometimes I feel like it's a better programmer than me. But the problem is I still have to code review its code before I accept it. So
totally.
Not always my favorite. But Copilot is going to pick what it thinks you might type next. You basically treating your program as though it was sort of a language, and write the next line of this poem.
Right.
And what that means is it's an interesting tool, but it's not a very predictable one. Because you don't know exactly what it's going to try and type next.
Yeah.
And there's a big difference between tools like that and code completers that are really good for using in an editor. Because if you are in an editor and you're writing code, you're in the zone, you are typing, 3 characters and then the tab key, because sort of almost in your hindbrain, what your code completer knows about your code, and already that it's going to be able to code complete this attribute access. And if you've been working with a completer for a while, you start to trust it.
Right. Get your rhythm.
The feedback loop between you and it gets very, very, very short, because even if you're looking at the screen and typing it, you're sort of type, up and down arrow to select the right thing and on to the next token. And what that means is that actually, if you're building a completer for that kind of rapid sort of, muscle memory stuff, it's really important to be predictable, to be consistent.
Yeah.
And one of the things that I find trips me up if I'm using one of these REPL systems that's sort of mixing, results from parsed code completion and results from going and inspecting the object in memory and telling me what attributes it has, is that I feel like I'm almost second guessing it sometimes, or it's second guessing me. And obviously, if I spent enough time with it, I get used to it, and so would you. But if you mix and match, how in this case I'm getting the information from the real object, in this case I'm getting the information from my best guess based on parsing your program.
Yeah.
Those are actually very two different ways of doing code completion. And if you're only doing one, it will work and not work in different ways and places. If you have a completer in a REPL, say that's just examining the running program, and then you write you write something that defines a parameter to a function and then uses it, the code completer won't help you very much because that variable doesn't exist yet in its world. Whereas on the other hand, it will be much more accurate than a parsing-based completer when it comes to inspecting an individual object that already exists in memory, because it can tell you the ground truth rather than having to stick a wet finger in the air and guess.
Yeah.
So yes, anyway, I'm just riffing on these awesome REPL tools with code completion, and there are many ways to attack various sort of versions of this problem, and it's fun to see how other people do it.
When I was originally exploring PyLance inside of VS Code, one of the features it had that I felt was very aggressive was it would suggest things that you had not per se imported yet.
Mm-hmm.
And it would auto add the import statement for that thing. Mm-hmm. So it would kind of say, did you mean this? Okay, well then I'm going to go ahead and just auto import this extra thing. And it's like, whoa. You've kind of and if let's say you let it complete that, and then you're like, no, I didn't mean that. It would still have that import statement up there.
Yeah.
And you're like, whoa, wait, wait, huh? And so there was some tuning they had to do to kind of like maybe chill that out, or settings that you could kind of adjust, which I thought that was kind of interesting.
Oh, yeah.
Potentially bad news.
Well, so while we're talking about code completion inside something like VS Code, I find VS Code's auto-completion strategy really interesting because it really brings to the fore. There's this difference in, basically, if you're writing a programming editor, it's basically either a text editor or it's an IDE.
Yeah.
So it's either an IDE like PyCharm that wants to know about everything in your project. It knows your virtual environment because it's sitting there, because it's got the run button built into the IDE and it's got a live debugger in there as well. It knows about all the files in your project because you've told it about them. And so
you're saying that when we started that, when you opened up a project, you could see it crawling across that stuff with the little progress bar.
Yeah. Oh, well, yeah, exactly. And it's done that. It's gone, indexing is the term that's used.
Indexing. Yeah, sorry.
And it will have indexed your entire environment. But what that means is it can be quite conservative because it kind of knows what's going on, because an IDE has a high degree of knowledge about your project. This is why Anvil is definitely an IDE. It knows more about your project than a typical IDE because it knows what your database looks like, which even WebStorm hasn't got to yet. Well, very difficult if you're writing a front end normally. But if you're basically a text editor, and VS Code is basically a text editor, then it's all a bit more approximate. So VS Code has these language servers. So there's this protocol, the language server protocol, that was pioneered by VS Code. It's a way that the editor itself can talk to some program that knows how to, for example, parse a Python program or work out what's going on in your Python code and offer code completions. And it's kind of at arm's length. There's this program that's, VS Code can open any collection of files, any folder, any individual file, and it's talking to your language server, and Pylance is a Python language server, and it's sort of looking over at these files on disk, and it's kind of having to guess what's around, what files are actually part of your project, what your scope is, where your module root is. And, it can be more or less accurate about these things. But what that means is that because you're in this text editor world, you're kind of biased to being a bit more liberal with your code completion. So something that VS Code will do that I don't think I've ever seen PyCharm do is, at a certain point, when it throws its hands up in the air and goes, actually, I'm not sure what's going on in your program here, it will start suggesting to you words you've written at other places in your program. Whether or not those words are syntactically or semantically appropriate, whether or not that variable is in scope, it'll, at the point where your cursor is, it'll go, well, I'm out of ideas. You used this variable name elsewhere in your program. Maybe you mean this. And that's kind of aggressive. It can help if it's dealing with a human who's very ahead of the game and understands that they are being given that you used this word elsewhere sort of autocomplete, and doesn't blindly trust the autocompleter, or no, not blindly, hasn't baked into their head that the autocompleter always knows what it's talking about. And I've come a cropper that way using VS Code because it's a very different philosophy. It's I'm fundamentally a text editor, and I have these plugins that will suggest smart autocompletions, but if I don't have them, I'll fall back to dumb ones. That's fine. Whereas IDEs philosophically will tend towards conservative code completion that only offers stuff that it knows is a good idea.
Truly earning the word integrated in some ways.
Yeah. Well, that is the advantage. Like, integration has the costs and has the benefits. Has the cost in that it's a bit of a pain to use PyCharm to edit like a random file while you want to edit a config file.
Right.
I will not choose PyCharm for that. But the benefit you get is exactly that level of integration and the things it can do knowing about your project.
Yeah. Cool.
But anyway, sorry, while you were talking about aggressive VS Code code completion,
no, it's good.
We're talking about the strategies.
It's all sidebars. I'm telling you. My friends occasionally have a dinner where it's like, whoops, all sides. And it's no main dish.
Yeah, that feels like this episode.
So I got a little bit. That's okay. It's really cool. Well, let me ask you the weekly questions here. What are you excited about in the world of Python right now?
Oh man! So the thing I'm currently most excited about is just today, as we record this, Raspberry Pi released so they have the Raspberry Pis, which are basically little cheap Linux computers.
Yep.
And then they've released the Pico, which is this like microcontroller thing. And now they've released the wireless Pico, and this is really big because this is stuff that's smaller, much more power efficient than a full-on Pi, cheaper, like $6 or something ridiculous, and it can now talk to the internet, and you can drive it with MicroPython. So we have one of these on order already. I can't wait to get my hands on it. I really want to have all sorts of little battery-powered Python gadgets around my house that can talk to the internet and then do really cool things. So yeah. The Pico W. Yeah,
it looks like around $6. That's pretty amazing. Cool. What's something that you want to learn next? It doesn't have to be programming or Python specific.
Yeah, so I think I'm going to answer programming because I've been thinking about programming. And I'm afraid that because I maintain a web-based development environment, as I may have mentioned like once or twice during this podcast.
What?
Really? Let me tell you about Anvil. So, I maintain a very large web application, and the thing I'm currently going down the rabbit hole on is different ways of doing state management in traditional web applications. And there's you've got your React and your Redux, and then there's all these other kind of interesting other approaches. Facebook have released an experimental one called Recoil. It's combination of intellectually fascinating and, like all JavaScript frameworks, subject to incredible churn, and it's hard to keep up with even if it's your job.
Yeah.
And it also definitely justifies sort of why did we do Anvil in the first place? Yes, because dealing with this kind of churn and complexity is the alternative. I like to say there's a dent next to my keyboard, forehead shaped, marked I am dealing with this so other people don't have to, and this definitely falls into the strategy, but I'm also totally down the rabbit hole and fascinated by how different people choose to manage state in a web application. So yes, sad, but that's what I'm learning next.
Cool. So how can people follow the things that you do?
So the biggest thing I do is Anvil. That's available at Anvil, anvil.works, WRKS. I am at Meredydd on Twitter, so that's MEREDYDD. But I try to tweet as little as I can get away with. So
sure.
If you catch me in an unguarded moment there, then congratulations.
Yeah.
Yes, other than that, we tweet at Anvil_works. I have a bunch of really interesting colleagues who tweet much more interestingly than I do, so go check them out.
Yeah, you got you've added a bunch of people to your team over the last year. That's great.
Oh, yeah. Also, I've talked about the Sculpt Python to JavaScript compiler out there, so skulpt.org. It's an open source project, and we are interested in, if you're interested in this kind of thing, then we are interested in you. Come join our GitHub, submit a pull request, have some fun. If you want to play with the inside of a Python compiler and parser for realsies and be one of these people who understands the pain of the old AST.C and why pgen is a really good idea, then come join us.
Yeah, cool. Well, Meredydd, thanks so much for coming on the show. It's been really great to talk to you again.
This has been fun. Really great all sides episode. Thanks very much for having me.
Don't forget, you can get simple cloud data connectivity to SaaS, big data, and NoSQL from Pandas, SQL Alchemy, Dash, and Petal. Learn more at CData.com. I want to thank Meredydd Luff for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.